Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk. When we were chatting about a couple different topics here real quick, and one that's like, I'm going to hit record because I have to do that. Otherwise, you and I talk about it for like 20 minutes, and then we don't know what to talk about when we hit record.
You know, after 8 years, yes, we still talk about lots of things we don't pick up.
Yeah, no, we should just hit record when we get online and just pick out the good stuff. The editing would be a nightmare.
Right. Good luck, Diane.
Yeah. But so before we get into it, is a topic I wanted to bring up with you is I wanted to throw out a request to our listeners. If you've listened to, say, more than 200 episodes or something like that, or 400 episodes, let us know. We're looking for a handful of folks that have listened to a slew of the episodes. And if you've got a favorite episode, or you like this or don't like that, or it made a difference for you, or it's useful, we'd like to invite you. And what we get in the analytics for podcasts is we get how many downloads there are. But as you know, as you're listening to a podcast, is your device or your software is just going to download stuff whether you listen to it or not. So we don't really know who's an avid listener who's just doing automatic downloads and never listens to it. So if you've listened to a bunch of them, you got some comments or feedback or favorites or stuff like that, and you would like to chat with Kirk and I about the show and your how it's made a difference for you, we'd love to hear from you. So please do get in touch. There's plenty of ways, as you know, to get in touch with us. We'd love to hear from you and get you behind a microphone, and we'll hit record with you. But Kirk, what I wanted to mention to you was that we were chatting about, the last episode we did was all this testing, and so many people are doing testing, the check the box, just do it. And you brought up the concept that, the folks in the lab say, this is not making any difference here. Nobody's paying attention to it. Why don't we do something useful? I've run into that on production floors over and over again, where the technician is, if we do this, it'll work a whole lot better.
Right.
And I, when I first got out of the military, I was in a factory. There were folks there that had been there for decades, and I learned so much from them about what to pay attention to, what not to pay attention to, what makes a difference on the equipment, what doesn't. Right. Years later, I was working on a circuit production line, and my introduction to graveyard was this woman was like half her body was inside this machine, fixing something, replacing some gear or motor or whatever it was. And she goes, yeah, hand me that wrench, give me that. And finally she got herself extracted from the equipment and said, oh, hi, you're the new supervisor? Well, at least you knew what your wrench was, something like that. So I took that as a compliment.
I know. Yeah. It's like a lot of the people that have and this is I've seen as a very common problem for me is when I go to a manufacturing line, and when I worked in companies and suggested that if an engineer develops a procedure, I think the engineer that developed a procedure should sit down and at least go through it once, live, or a couple times, or half a day, which is not asking a lot.
No, it's
to
like
sit out
shake out
and
the
run
stuff, actually make it,
and see. Or occasionally come down to the manufacturing line and talk to the workers, because they're in almost all cases, especially if after they've been doing it a while, they know what the problems are. You talked about they know what is important and what isn't. And they probably skipped part of the procedure that they realize has very little value, and they know which ones to focus on, even though the engineer would say, you skipped that? No, yeah, we've done that 1,000. We know where the problems are. In fact, the frontline worker is generally the one the most educated, most knowledgeable about the problems in either assembly or manufacturing that causes issues, not necessarily the design, but how the procedure is designed, how the assembly procedure is designed, and we have the design for manufacturability, having the same size screws as much as possible, things like that.
Yep.
And they know why, that's because they're doing the work. So I think it's very difficult. There's kind of a class separation in many companies.
I got lucky. I worked in factories where, I was on the same floor. I was on my office was kind of one cubicle wall away from the equipment.
Right.
It was, whereas so many factories, so many of our clients, their factories in a different country, in a different language, in different time zone.
Right.
And so they're, I'm thinking, I was just, listening to the news about NVIDIA, and they stress that, well, we don't make the chips. They're asking if they were going to benefit from the CHIPS Act and get any money for that to set up a fab. He says, well, we don't make chips. We just design them. We design them and we farm them out to other places to make them.
Yeah, any fab can, most fabs, depending on their dimensional capabilities, can make that chip, like TMST, Taiwan Semiconductor Manufacturing.
Yeah, but it's, and
TSMC.
But those engineers are designing stuff that they hope these other folks can actually make. And they must spend a lot of time working because of some of the high zoot stuff that's going on. It's crazy.
Right.
What I've run into too many times where the ivory tower engineers are loath to go down to the floor. And even when it's just upstairs, downstairs. And I'm like, no, you need to actually go down to the floor and talk to people and watch the process. And if you're putting in a measurement system, how much of a pain in the ass are you causing to these people?
Exactly. Right. Just try and do it yourself. Just sit there and do it. I mean, if you wrote it, you know how to do it, right? So go ahead and do it. But yeah, there is a kind of a class difference many times in siloed in the companies. I won't lower myself to go down to the floor. So,
I'll get dirty or something.
Yeah, I'll get dirty. I got my tie or whatever, and some companies like Delco, it's very, by the dress, it was very clear who was who, and also union. But other places, it's just they've been divided for a long time. I know certain companies like HP try to make it more egalitarian, I think, where everybody has cubicles. They don't have wall offices. I noticed that.
Yeah, nobody in the whole corporation has an office.
Nobody has an office. Whereas, when I started with Storage Tech, the managers got offices. And Dell, they didn't have offices either. So you had to go to a team room to have a private chat.
Yeah, but even still, is that when I worked in this factory years ago at Raychem, the upstairs in the front of the building was the engineering floor, basically.
Right.
And there's engineers and techs all had our early on computers, and we were doing our stuff up there. And the engineering manager did a whole bunch of stuff that I, value to this day. But one of them was, you got to be on the floor.
That's right.
We don't have that many employees. You should know all their names. And
we call it management by walking around, right?
But he said the other thing, why it's important is that they're busy, moving parts and, making measurements and packaging stuff and producing these products. And they're doing their job and they're doing their stuff. Is that when you are on the floor and get to understand what they're doing, you bring in a perspective that they don't have the luxury of the time to do it. So I could watch a production line for an hour and a half.
Right.
And I'm watching, time and motion and where's the racks and how's the setup and what can we do to improve it? What's the barriers? What's the hurdles? Where are the areas where there's extra variability? I'm considering things because I have the luxury of not having my hands busy the whole time.
Right. You can look at the whole scale or the more macro level of the product flow, the steps and transport between stations, and see the whole system. And in fact, that's your job.
Right. And so then it was always a part of just change management. If you so Bill, what do you think about, if we did this, this, and this, would that make a difference? And he'd say, well, I've been thinking about that, and it might be better this way or that. Once they trusted you, they weren't going to be put down or demeaned or anything else. Once you gain some credibility or some trust, then they would say, I'm glad you're listening. Think of it this way, it improves their lot in life, their contributions and their work environment and all the other stuff they're doing. They contribute to the process. And then I have the time to go make their ideas work. And then the thing I really learned was the more you give them the credit because it was their idea or their suggestion, the more ideas and suggestions you get.
Exactly. Exactly. Give credit to the person who actually knows how to do it and has been doing it for a while and has a good idea and probably knows how to do it better or has already made a way to do it better and not said anything. They may skip part of the procedure and just go to the next part of the procedure. And,
years ago, and I'm sure you've run into this in your circuit board times and working with people, is they had a long connector of some kind of cable connecting system. There was the part of it was mounted on the board, and it had a through hole part. That would with straight pins. Right? And so they would place the capacitor or the connector on the board, and then they'd run it through a wave solder. And one of the things about a wave solder is that liquid lead will push the lighter components up, before it solders to it.
Exactly.
And so we saw that in some of the first sets of prototypes, and then we and so we monkeyed around with what we could do with temperatures and rates and orientation or a bunch of other stuff, and none of that really works. I get on the phone that day to the engineers back home and says, hey, we're having this problem. What kind of do we have any connectors that have a detent in it or a friction fit or a clasp or something to hold it in place? And they're like, it costs money, blah blah blah, and it'll take 75 years before we get the part, blah blah blah. And I'm like, all right, whatever. So I mentioned it to the guys on the line, and one of the kids, this guy is in Singapore, and tech on the line or the operator on the line looked 12, but I was in Singapore and everybody looked 12.
Yeah, they do.
And he looked at it for a second because I think I have a solution. So overnight, because of the switch in time zones, I get an email from these guys back in the States saying, oh, we've got this mechanical hold down board. You put this on, you tighten this and turn this cam and do this and do that. And it was a mechanical marvel that they'd whipped up just for fun, I guess. I don't know why. And it would cost about $5,000 for each one that we made. And we needed like 50 of them.
Yeah.
And then they would wear out after 10 cycles because of the materials on it. And like, no, don't bother. Don't make that. Don't make that.
Not going to be.
Meanwhile, this guy on the floor comes in and he has these little sandbags. He said, I have this thermally resistant fabric that we filled with ceramic, like pie weights. Yeah. And it's a little sandbag, a little mini sandbag that we put on top of the component.
And it holds them down.
It holds them down, and then at the end of the line, you pick up the sandbags and put them on the next one. Yeah, exactly. And they lasted forever.
Yeah, yeah.
He goes, yeah, my aunt made them for me. If she wants some more, we'll have to pay her.
You can get them embroidered, too.
Yeah. This is a left-handed connector, and that's the right-handed connector and stuff like that. But it was it was
a real simple,
brilliant solution, but with in profound knowledge of that production line and what was required, what was needed.
Right. Yeah. The people closest to it can see, the real physics of the assembly going through, and you could go up and try and explain that to the engineer, and he said, "No, I did that." Believe me, it happens, and let's go down and see it. No, I don't
want to go down there. I'm not going down there.
It's right. Yeah. Oh boy, it's just I like being down there and seeing the hands-on. And I mean, when I was a manager at Storage Tech, I'd always be walking around and seeing what they're doing, and trying to talk to the managers that we supported as we were the equipment maintenance group, and making sure that that they were happy with the work we were providing and what my technicians were doing.
Yeah. No, it's an amazing. One of my clients was a bottling company. They were making juice, is the line that I was working with. And this one piece of equipment was, I don't know, it was probably 20 feet in diameter. And it would fill like 1,000 single serving size bottles of juice a minute. It was just amazingly fast, and gears and cams and stuff moving all over the place, and nozzles and.
Right. I worked on the canning line at Dr. Pepper, and it's amazing how many cans can go through this giant, 16-foot diameter wheel, seal, and then
it gets rolled off, gets
rolled
pasteurized
off,
and cleaned, and it's just.
Oh man, it is so fast.
And this is nozzle or station number 48, has a problem, and. How did you see that? The stuff's moving it beyond. You can't make out individual bottles. They're moving too fast.
Right.
But they have sensors all over these things.
Oh yeah.
And it is absolutely amazing, the complexity of these custom machines, and just I am fascinated by how stuff gets made. I always have loved going to see how stuff gets made, and so. I live in the Bay Area, and the Jelly Bellies. It's a
jelly bean.
Jelly beans that are made as a brand of them, and they have a tour. You get to walk around. There's a platform that goes around the upper part of the production floor, and I look down at the production floor. And I'm expecting to see these lines, production facilities, and it goes one step to the next. No, it's a. It looks. I think they were converted. Cement mixers. It's probably a 2-foot diameter a barrel, and had a motor on it, and you could tip them forward and back, and they would get, I don't know what the starter was, but they'd have a piece of something that, and then they would layer in different layers of sugar probably, or whatever it was they're putting in there. They had a scoop, and they'd layer it in, and it'd tumble, and
it's almost like polishing rocks.
It is, yeah, it is very much, and it was kind of done. It's temperature controlled and a bunch of other stuff, but they would build these things up and to the particular size, and they take it out and measure it and go, okay, that's good. And they dump the batch and then they get packaged. And it was 50 cement mixer things.
Yeah.
Barrels running to make the different flavors.
It's, and these companies that develop it, these pieces of equipment, I guess is, the engineering behind it is pretty amazing, for them to, of course, jelly beans have been around for a long time, so that's not new technology, but the efficiencies, I'm sure the volumes and things like that, especially for somebody successful like Jelly Belly is pretty incredible.
Yeah. No. So parts of it is process control, so. Part of it is, continuous improvement. Part of it is the resilience of dealing with the changes in design, new components, different problems that crop up from time to time.
Right.
A lot of the stuff we do in reliability can learn a lot from a good production line, and how they, when it's designed and how it's built and how resilient it is to all the various changes that can occur.
Right.
But the linchpin, I find, is listening to the folks closest to it. And
Exactly. They know what goes wrong. They see the end of the production line. They pick up the product. They rework it. They're the ones that really do the hands-on. And I mean, I just without engineers become better engineers if they go down there and they start interacting with the workforce and people actually doing the work and actually listening,
learning.
Seeing, observing, with the workers, showing them and explaining, and not just looking at the numbers coming off the manufacturing line, what, failures versus, but actually looking at what the workers are seeing and how they're correcting it on the line, and they may be just constantly trying to repatch something that's coming off the line, and without the engineer or coming down to see it, they really can't get their attention. So it's really critical to success for the engineers to come down and interact, and go break those walls down between the upper floor and the
well, it's
the
also
ground
yeah,
floor.
and it's the same with the technicians. It's the same with the field service folks. It's the same with the rest of your organization. There's a lot of talent out there. We need to listen to it.
Yeah, I don't see many that's another thing. Field engineers coming back in and having a real discussion, like an annual meeting with the engineers about
Oh,
the
it
design.
should be monthly.
It should be monthly. It should be as often as it can, reasonably. But if they're actually out in the field, distributed everywhere, I mean, now you can do Zoom meetings or something like that. At least you'd have that. But to be able to get, stand next to the equipment in the factory and talk with the guys that have been repairing it out in the field, like when I was repairing ion implanters and all kinds of high vacuum equipment, talking about the problems I had, the challenges and things like that, and how they could make it better. But that never really occurred because we were
off fixing stuff that didn't work and didn't get designed. So if you'd like to continue in that rat race of just constantly fixing stuff and nobody's listening to you, have a good time. But you can listen to podcasts while you're traveling. But if you if you've seen good cultures or good places or stuff that you've learned from folks on the front line, basically, I'd love to hear those success stories and all that good stuff and what's working, what's not. What are the barriers to make that happen? And sometimes there are real barriers, like time zones and language barriers and all those things.
Yeah.
So you still can get a long way if you make some effort on it. It's my contention.
Right.
So we'd like to hear about it. Head over to ascendoreliability.com/go/SOR. A couple of ways for you to get in touch with us there. And by the way, if you are a longtime listener, one, thanks, and two is let us know so you can participate in our 1000th episode. We'd like to get some people with what's worked for them or what they liked or don't like or whatever. If you'd like to get on the air with Kirk and I, let us know. But you also can find Kirk and I and the other hosts of the show on LinkedIn and our About pages. So there's plenty of ways for you to get in touch. And as you know, especially if you've been a long-time listener, I ask for your questions and comments pretty much every episode. I think I missed one a couple of years ago. I'd have to check.
Well, I like your new pronunciation, ascendo. I know you talked about that in one of your podcasts.
Yeah.
It's not accendo, it's ascendo.
Ascendo, yeah. Apparently double consonants in Italian or in Latin are just pronounced differently than, each one has its own variation of how it's pronounced. But a colleague of ours and a contributor to the site hails from Italy, and he corrected me. No, it's ascendo. And I may still not be getting it exactly right, so I'm working on that. But the term itself is Latin, which has been carried over from Latin into Italian, and so it's in common use to mean the light, the way, kind of thing, the illuminate.
We hope we've illuminated your path to better reliability.
Sure. That just sounds just too cheap. Thanks, Kirk.
All right, Fred.
We'll talk to you later.
Always good to talk to you. We'll talk soon.
Yeah, take care now. Cheers.
Okay, bye-bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.